In the previous video of this series, we talked about neural network layers like convolution and pooling that are mostly used in CNNs. In this video, we are going to discuss some layers that are commonly used to process sequential data, like natural language text, in recurrent neural networks. These layers are made of basic building blocks called cells, so this video will mostly be about those cells. First, let's look at simple RNN cell.
This is a simple RNN cell, which is also known as a vanilla RNN cell. As you can see, hidden intermediate value H is fed back into B added to the next input of the sequence. We can unroll the feedback loop like this. Now, it's evident that some information about the previous stage is passed on to the next stage as a kind of short-term memory in a sense.
However, vanilla RNNs have a major limitation known as the vanishing and exploding gradient problem, since the same weight matrix is used at each time step. Therefore, it is not well suited for processing long sequence of data, as the vanishing and exploding gradient problem can become more severe with longer sequences. To overcome this issue, LSTM or GRU can be used.
This is an LSTM cell, which is short for long short-term memory. Here, CT is called the cell state and it represents the long-term memory. Since there are no weights directly interacting with the green light, it doesn't suffer from the vanishing and exploding gradient problem.
Just like in an RNN cell, hidden state HD represents the short-term memory. This section of the cell calculates how much of the long-term memory should be discarded and therefore named as the forget gate. This section, which is known as the input gate, determines how the input should influence the long-term memory CT. Hidden state HD is also the output of the cell. This section calculates HD and therefore known as the output gate.
However, LSTMs are more complex than simple RNNs, with more parameters to train and more intricate internal structures. This can make them slower to train and harder to optimize. Therefore, one can use GRU as a compromise since they are less complex than LSTM.
GRU stands for Gated Recurrent Unit, and it is a type of recurrent neural network that is designed to process sequential data. At its core, a GRU cell has three stages: an update gate, reset gate, and an output gate. The update gate determines how much information from the previous time step should be stored in the cell's memory. The reset gate determines how much of the previous hidden state should be forgotten. The output gate determines how much of the current state should be used as the output. Now, let's talk about the unrolling process. When we unroll a GRU cell, we basically replicate it over time, creating a sequence of interconnected cells. Each cell takes as input the previous hidden state and the current input, and produces an output and a new hidden state. One of the key features of GRU cells is their ability to store information in their memory. The memory allows the cells to keep track of previous inputs and hidden states and use them to make predictions about the future.
As we mentioned before, since GRU has a simpler structure compared to LSTM, it should train faster and be more computationally efficient, while still being able to capture long-term dependencies in sequential data. Therefore, it can be more suitable than LSTM for smaller datasets and simpler problems.
If you enjoyed this tekcerpt, please like and share. If you have any suggestions, feedbacks or questions, don't hesitate to comment.
And to stay tuned, please subscribe and hit the bell icon. See you soon.